Okay, so here we are with the question number 3, and this will be the last question for tonight. The rest of the question will be recorded by tomorrow. So now we have the gear A has a mass of 1.5 kilograms and the radius of gyration given to us as 0.15 meters. The coefficient of the kinetic friction between the gear rack B and the horizontal surface is equal to 0.3. Okay, so that's the friction between these two surfaces, as you can see in this diagram. Now, if the rack has a mass of 8 kilograms and initially moving at the left with a velocity of VB1 is equal to 4 meters per second, then mind what will be the constant moment M, which must be applied to the gear to increase the motion of the rack in the time equal to 2 seconds to have the velocity of 8 meters per second to the left. Neglect the friction between the rack and the gear and assume that the gear exerts only a horizontal force on the rack. So to understand this example once again, the gear is rotating with a certain amount of torque, or moment, sorry. Initially, the rack is moving to the left with a velocity b of 4 meters per second. What will be the moment after 2 seconds to increase the velocity at the b to 8 meters per second? So the free body diagram for the gear will show me the following. We're going to have two reactions at the point O, horizontal and vertical one, and we have the mass of it going downward. Also, we're going to have the friction force, the force exerted by the rack on the gear, which is going to be opposite to the movement of the rack. The rack is moving that direction because the gear pushing it to the left, while the rack itself is going to be pushing the gear by resistance to the right. So these are the forces. And the other side, for the rack, the horizontal one, we're going to have normal force, friction force. Try to resist the movement to the left by going to force to the right. And we're going to have the force exerted by the gear going to the left and the weight going downward. So you can see that the solution is going to be done by first, we're going to have the two omega 1 and omega 2 on the gear. We have the velocity 1 and velocity 2 on the rack. So that means for the gear, we're only going to have the one of the equations is going to be just the momentum equation. And for the rack, we're going to have only one equation, which is going to be the x-axis velocity force equation. And we solve for that, and we'll find the value for the force and the value for the moment together. So we're going to have two bodies. We have the gear A, which only have a rotation about a fixed axis through the point O. The gear rack is going to be, I have only a rectilinear translation horizontally. So we can either consider that the A and the B are going to be one system, and this can eliminate the internal forces between them, but using this result, the resultant equation written in a simpler term can be complicated. So the other option is consider the A and the B to be treated individually. So in that case, this will be the free body diagram for the gear, and this will be the free body diagram for the rack. If I would like to have the moment around the point O, it's only going to be equal to the moment in negative direction plus the FA multiplied by the radius. And this will be changed from the time 0 to 2 as we mentioned earlier. No vertical velocity, no horizontal velocity in this one. In that one, we're only going to have two velocities, linear, 4 and 8, and the time is going to be in 2 seconds. So we have the mass of both. I can calculate the IG for the circle and continue with the solution by using the sets of the equation that we mentioned earlier. So the knowns we have here is going to be the mass for the gear is going to be 1.5 kilograms. The KO is 0.15 meters, so we can calculate the IG. We know that the mass for the rack B is 0.8 kilograms and the coefficient of friction is given as 0.3. The velocity 1 is 4 meters per second. The velocity 2 is negative 8 meters per second. And the delta t is going to be equal to 2 seconds. The unknown is just the moment for the gear. So the set of the equation we said for the gear is going to be the 3 equations. For the rake is going to be the 3 equations. But we're not going to use them all. Because first, we don't have any velocities in the case of the gear. Not left, not right. And we don't have moving forces. So simply we can consider that the first 2 equations are not going to be useful. Just the momentum equation will be used. In the case of the rake, we don't have momentum, we don't have vertical movement, then we can use only the equation D. So among all the equations, only the C and the T equation going to be applied. Now, when you look at the first equation, yes, I can calculate the IG. I know the omega 1 and the omega 2. And I can calculate the moment around the point O, which is going to be the moment and the effects of the force F on the gear, multiplied by the radius. For the other part, the mass is known, the velocity v1 is known, the velocity v2 is known on the other side, and the force X is not known now, which is going to be the friction force, and we have the force from the rake to the gear, and we can simply find that. So we can start to do the calculation for the gear A. First, start to calculate the IB, which is going to be the mass multiplied by the radius of gyration for it square. So this will be simply equal to 1.5 multiplied by 0.15 square, and this will give me 0.03375 kilogram meter square. Now we are going to apply the equation for the momentum. We said that the HO is the IO omega A1. The HO2 is going to be the IO multiplied by the omega A2. So we know that this omega, because there's no stemming between the gears and the rake, the velocity of the point of the contact was 4 first and 8 second. So we can find the omega 1 and the omega 2 by applying the equation of the omega is equal to velocity divided by the radius. So we're going to have the omega 1 is 20 radian per second, the omega 2 is going to be 40 radian per second, and both are clockwise. That means that both are negative. So now we're going to put them in the equation here. And we will come to that the moment is negative because it's going to go to the clockwise direction, while the FA multiplied by the 0.2 will make a positive momentum. And thus, we can have this equation. We can solve for the value for the FA as a function of the M. I cannot actually find the FA now. I have to wait until I get to use the other part, and then I will come to the FA value and then substitute it here. So we go to the rake. For the rake gear, we only have a horizontal movement, horizontal velocity. So we're going to have the mass multiplied by the velocity 1 is going to be equal, plus the sigma of the forces in the x direction for the rake is going to be equal to the mass multiplied by the velocity 2. So now we're going to write down the equation with more expanding. So we know that the mass is given to us as 0.8 kilograms. The velocity 1 was -4, so this will have a negative value, of course. And plus the FA, which is going to be negative now because it's going to be opposite to the first case, multiplied by the time of 2 seconds, plus the friction force multiplied by 2 seconds is equal to negative 8 multiplied by the mass of 0.8. Okay, it's going to be this equation. Now in this equation, once again, the FA and the FF are unknown. Anyway, we're going to put everything in. you can see that we choose that the FF is equal to 0.3, which is coefficient of friction, multiplied by the mass, because we can find that sigma of the forces to the y direction for this rake is equal to 0, and thus the normal force is equal to the weight. Okay, so the weight is 0.8 multiplied by 9.81. And then we're going to multiply it by the coefficient of friction, multiplied by 2 seconds, and this will be the FF delta T. It's positive because it's going to go to the right, while for the force of the gear, or on the gear, is going to be negative in that case because it's going to be a reaction of the first one. And thus we can find that the answer can be found for the FA directly from here. So actually I put what the meaning of each one. So we can find the FA to be 3.95 Newton, and then put that in the equation number 1. We're going to find that the moment is going to be equal to 1.13 Newton meter. Okay, so that's the end of the question number 3. And as I mentioned, that the rest of the question will be recorded by tomorrow.